So now we're going to shift into a discussion about functions. A relation that is a rule that relates two quantities is a function. Such a rule pairs the element in one set A with the elements in another set B. And the set of all inputs is the domain of the relation. The set of all, and the set B contains all the outputs or the range. Relations are commonly represented in four ways, and this is really important because if you go on to calculus, these four ways are drilled into your head. So the four ways are verbally, so with sentences that describe how the inputs and outputs are related. Numerically, so a table of values or a set of ordered pairs relates each input, x, with each output. Graphically, points on a graph in the coordinate plane represent ordered pairs. And then algebraically, so an equation that relates x and y coordinates in an ordered pair. You have seen all four of these, and all four of them can be used to represent different kinds of functions. A function is a special type of relation. It is a relation that assigns every input in the domain to exactly one output in the range. That is actually called being 1 to 1. So, in words, a function f from set A to set B is a relation that assigns to each element x in a set A exactly one element in set B. So that is the verbal definition of it. In symbols, and we're looking at this set or these two sets of information right here. The relation from set A to set B is a function. Set A is the domain, where the domain is the set containing 1, 2, 3, and 4. And B contains the range, and the range is going to be 6, 8, and 9. Now, the function itself happens in the arrows. So the function rule happens that takes each one of these inputs and maps it to one output. What you might notice is that you have the 2 and the 3 mapping to a single value, and that's okay. But what you don't want to have happen is you don't want to have something in this set mapping to two separate elements in the range. That will actually mean that it's not a function. We're going to talk about what that means in a minute. The outputs do not have to be unique. However, one input cannot be mapped to more than one output and still be called a function. So you can also think of this as a set of ordered pairs where no two different ordered pairs have the same x value. If we look at this graphically, which is probably the easiest way to look at it, no 2 points on a graph lie on the same vertical line. This is actually called the vertical line test. So this is probably going to be the easiest way for you to determine whether something is a function. You should be able to draw a vertical line anywhere in the function and see whether or not it passes through at 2 points. So let's try an example of just determining whether something can be called a function. So if I have the input of x values of student ID numbers and the output of y values, which is the student score on a physics exam, if we just want to try to diagram it, well, if I have a set of student ID numbers and a set of scores, and I have student 1, student 2, student 3, student 4, basically what I can have is, okay, well, I can have some scores that are like, 75, 80, 92, 96, 54, and I can say, okay, well, each one of these students, well, student 1 got a 75, student 2 got an 80, student 3 got the 54, unfortunately for him, and student 4 got the 92. What you should notice is that each one of these test scores is unique, and that no single student scored two different scores on the test. You don't want to have one student scoring two scores on the test. So this is actually a function. If we look at B, I have a table of values where I have x and y. So I have -8, -5, 0, 3, and 6, -5, -4, 3, -2, and 3. So what we're looking at or looking for in the table to determine whether this is a function is I'm looking for two x values that are the same that map to two different y values. And in this, I notice that each x value is unique and it maps to a y value. So this is actually a function. The last one is the graphical, and this is probably the fastest way that you can always test. Um, is that if we draw a vertical line and you see that it fails the test because it passes through here and here, since this fails the vertical line test, this is not a function. It's not a function. So graphical is probably going to be the easiest way for you to determine whether or not you have a function. The table of values, or the sort of the mapping drawing, or the table of values will probably be your next best bet. If you're given an algebraic equation, I would suggest that you try to graph it and see what you can do, or create a table of values. Since we're dealing with functions, we also have something called function notation. It's interpreted as the value of the function of x. Because f of x, which is how we read it, corresponds to the y value of f for a given x value, you can write y equals f of x. So basically, if I give you an equation which is y equals negative 6x, you can relate it to a function that says f of x, which is negative 6x. Because it can represent any value in the function's domain, x is called the independent variable. A value in the range of f is represented by the dependent variable y. So you've probably seen this written as sort of like a function machine, where you take the value of x and it's the independent variable, so you can change it, and you plug it into your function, and it does the rule, and then it spits out the y value, or the output, which is the dependent variable. So let's try this, and let's try to evaluate some functions. Let me see if I can make this bigger for you. Okay. So the first one says, okay, evaluate g of 6, and this is how the input will work. So that means wherever you see an x, you're going to replace it with a 6. So this should be 6 squared plus 8 times 6 minus 24. And if we clean this up, this is going to be 36 plus 48 minus 24. So then I can combine these again. So 36 plus 48, let me get my calculator because I can't add. 36 plus 48 minus 24 is going to give me 60. So when this is all said and done, this is actually going to simplify out to 60. Now the good thing about functions is that we don't actually just have to pass in numbers. We can pass in anything we want and we can evaluate it. So if I say take g of negative 4x, well, that means that wherever I see an x, I'm just going to replace it with a 4x. So this becomes negative 4x squared plus 8 times negative 4x minus 24. And if I want to evaluate that and clean it up a little bit, well, if I square this, this is going to become 16x squared minus 32x minus 24. Why don't you try the last one? So one of the things that we have to deal with when we're talking about functions, especially when we start talking about more complicated functions, is talking about the domain of a function. And let me get this out of the way. So we've already established that the set of all inputs that are acceptable is going to be the domain of the function. Now, when we start talking about more complicated functions, or you're given a function with an unspecified domain, the implied domain is the set of all real numbers for which the expression used to define a function is real. In general, and this goes for any kind of complicated function, you must exclude values from the domain of a function that will result in a division by 0, or taking the even square root of a negative number. So that's square root or fourth root or any sort of even root of a negative number. The domain is then written in either set builder notation or interval notation. Now, generally the way this goes is that you're probably going to want to use set builder notation, because set builder notation is very good at excluding values. Interval notation, I'll tell you right now, is only really good when your domain is either one-sided, so it's an unbounded on one side, or if the domain is all real numbers, which would be negative infinity to positive infinity. Otherwise, if you have to exclude any values, you're going to want to use set builder notation to do it. So let me demonstrate. Find the domain of each function. So if I look, at the first function, it says 2 plus x over x squared minus 7x. Since this is a fraction, I don't want to have a 0 in the denominator. So the way that I determine this domain is that I just want to have every number except for everything that makes this 0. So I'm going to take the bottom out of this fraction and I'm going to set it equal to 0. Well, now I just solve this algebraically. Well, I'll factor out an x, and you'll get x minus 7 equals 0. And I'll solve, and so I know that x, in this case, equals 0, or x equals 7. So for these two values, I will take it, and since if x equals 0 in this case, I'm going to get a 0 in the denominator. Or if x equals 7 in this case, I'm going to get a 0 in the denominator. So for the domain of the function, x cannot equal 0, and x cannot equal 7. And so what we'll do is we'll take that and we'll write that in set builder notation. So I'm just going to build around this. So I'll have the domain, or D for domain, is the set x such that x cannot equal 0, x cannot equal 7, but any other number other than those will work. So I'm going to assign x to the real number system. And generally when we're talking about domain, we're going to assign to the real number system. Okay? So for fractions, you can't divide by 0. Can't do it. If we're talking about square roots or any kind of root, the problem with the square root is that you can't take the square root of a negative number or else your calculator is going to freak out at you. So essentially what I'm going to do is I'm going to pull the inside of this square root out, and I'm just going to figure out, well, where is it greater than 0? Or greater than or equal to 0? Because I want it to be positive. But it can also include 0. You can take the square root of 0. So to do that, you solve your inequality and you find that t is greater than or equal to 0. And so then you can take this and you can write it in set builder notation. So I can say, okay, well, the domain of this function is the set t such that t has to be greater than or equal to 0. And since we're also dealing with real numbers, we're just going to keep assigning it to the real number system. So what we want to avoid is that roots can't be negative. Can't be negative at all. And so if we take this and we take these two concepts and we apply it to the last one, we get something very interesting. So here I have a fractional function, or a rational function, but it also has a square root in the bottom. So we have to deal with two things. One, we can't divide by 0, and two, this square root actually has to be positive. So there's a couple of things that we're going to do. Normally, we would say that we would deal with the inside part and would say, well, x squared minus 9, we're going to figure out where that equals 0. And since we can't divide by 0, and this has to be positive, I would also need this to be greater than 0 or positive. So we're actually going to take this, and this actually turns into, well, x squared minus 9. And since it can't be 0 because we can't divide by 0 and it has to be positive, we actually have to just say that it has to be greater than 0. Mostly because we can't have it equal 0. So that equal to, like in this one where we were able to have it be greater than or equal to, it's not allowed to equal 0 since that would make the function undefined as well. So we're going to solve this here. So this is x squared minus 9 is greater than 0. Well, this is the difference of two squares, so I can say, well, it's x plus 3 and x minus 3. And that has to be greater than 0. And so what you'll end up getting is x has to be greater than negative 3, and x has to be greater than 3. And so what I can do is that I can write this in set builder notation. I cannot write this as a compound inequality, but what I can say is, well, the domain is the set x such that x is greater than 3 and x is greater than negative 3, and x is greater than 3. And x is still in the reals. So the last thing that we're going to look at tonight is something that you've probably never seen before, but it's not too hard. So a function that's defined using 2 or more equations for different intervals of the domain is called a piecewise function. And a piecewise function looks like this. So if I give you a situation which says the average maximum height of children in inches as a function of their parents' maximum height in inches can be modeled by the following piecewise function. Find the average maximum height of children whose parents have given the maximum heights. Use h of x, where x represents the independent variable. And I lost some of the question. Sorry. Where x is the independent variable representing the parent's height, and h of x is the dependent variable. So, for example, if I just want to evaluate h of 67, well, okay, if this is my variable, if this is my x that I'm passing in, I'm going to take the 67 and I'm going to compare it and find in between which interval does it fall. And then whichever interval it falls, then I'm going to do that function rule. So I take the 67, well, 67 is not between 63 and 66, so I'm not going to use this first line. But 67 is between 66 and 68, so I'm going to use the second line to evaluate this. So it's going to be h of 67 is 3 times 67 minus 132. Well, if I do 3 times 67 minus 132, 3 times 67 minus 132, I'm going to get that the maximum height is going to be 69 inches. And if I wanted to evaluate h of 72, well, I take the 72 and I apply it and I go through the inequalities again. Well, 72 is definitely not between 63 and 66, so it's not here. 72 is not between 66 and 68, so it's not here. So 72 is definitely bigger than 68, so I'm going to use the last line to evaluate this function. And so h of 72 is 2 times 72 minus 66. And if I evaluate that, so 2 times 72 minus 66. And that's going to be a maximum height of 78 inches. Another thing that we can do is that we can start using these values and we can start getting points from them. But why don't you try one more on your own? That is it for this video. We're going to do some activities with this tomorrow. If you have questions, please make sure that you bring them to class so that I can answer them, and we will do it during a reteach block. Have a great night.